Number 5 is discussing titrations. So we need to look at some formulas here and make sure we understand what we're working with here. So in a titration, keyword being titration, we'll circle that here for a moment. We have a given volume and a given molarity, that's our concentration of calcium hydroxide, that's our base. And then we're telling required, usually I'll say required or results in, something like that, to neutralize. There's another keyword, and we're given another volume, and it's our nitric acid. All right, so we have an acid, we have a base, we're going to put them together, neutralize them. And we do have a special formula that we use in chemistry here. I will put it up on the screen in just a moment. But they want to know, given these 3 pieces of data, the volume of our base, the molarity or concentration of our base, and then we're given the volume of a particular acid, what would be the final concentration of our nitric acid in this example. So again, keywords: titration, required to neutralize. They'll say neutralization reaction. Just watch for those keywords, and you'll start seeing volumes and molarities. I would automatically think this particular formula here, MAVA, MBBB. Okay. Let's see here. I'm going to go ahead. And this is just for clarity here, this number NB. Yeah. So we have MBBB. All right. So if we have, and notice here, they did not give us the formula, right? So we need to make sure to have the correct formula. I know that calcium hydroxide is, I'll put this over here, CaOH2. That's because calcium is a group 2 metal. And if we go over to the acid side, we have nitric acid, that's HNO3. So notice I have every molecule on the acid side has 1 H, while every base on the base side, or OH on the base side, has 2. Okay, so we have a 2-to-1 ratio. It's not equal. It's not equal. So we have twice as many hydroxides per molecule than we do on the acid, on the base versus the acid. So it's something we need to account for. And this is what that number here. And we just put in a coefficient. I just put in the number of hydrogens per molecule to keep things straight. All right. Now I will, just as a side note, some teachers want you to write the balanced equation. No harm in that whatsoever. However, you should be, by the time you're getting to finals, you should have already done these a few times, as long as you know how many hydrogens are in the acid molecule and how many hydroxides are in the base molecule. You really don't need to go through all those steps. Okay, you can account for that in the basic formula that we have. So given that, I'm just going to go ahead and put 1 here and 2 here. Okay, so we have our acid on the left, base on the right. We'll get that taken care of. Molarity of our acid, we don't know that, right? That's an unknown. I'll just put MA. Volume of our acid. All right, so notice we have, I mean, we could technically, we're supposed to put them in liters, and then we can go back to millis if needed. But as long as they're in the same, they have the same prefix, they're millis, we don't need to worry about converting to liters. I wouldn't worry about it. I would just say, okay, 18.3. Okay, and then we do have our molarity of base. That's the 0.80. And then of course we have 17.1. Okay, so we could, again, technically in the 17.1 and the 18.3, we could just divide out by 1,000 to represent liters, but you'd be doing it on both sides, and it's just going to cancel from a mathematics perspective. They're just going to cancel out. Don't worry about it. All right, so we have 1 times MA times 18.3 on the left. I'm just going to put 18. I'm just going to go straight in algebra mode here. And then I'll go ahead and multiply everything out on the right-hand side. Notice I only had a 1 and an 18.3, not much to do there on the left, but I am going to go ahead and resolve what's on the right real quick and say, okay, well, I have ultimately this product on the right is 27.36. And okay, so we'll end up dividing because this is a multiplication on the left, and we're just trying to isolate that MA or molarity of acid. We're going to divide both sides by 18.3. So, thinking it's not going to be very much. It's not going to be very much. It's going to be like 1.49. Okay, so 1.5 millis. Wow. Yeah, I get 1.495. Actually, I'm sorry, that's not millis, that's molarity. So we could say, all right, we have 3 sig figs everywhere, 2. Okay, I would say, gosh, I would say this could be bumped up. Yeah, this would be bumped up to 9. Yeah, 495 is just going to be 1.5. We'll leave it at that. And this is molarity. All right, thanks for watching.